Today, we're tackling the absolute backbone of Linux administration: users, groups, and package managers. Before we jump into today's interactive session, take a quick second to hit that like button and subscribe to our internal channel so you don't miss out on any future onboarding modules. All right, grab your notes because what we're covering today, you're going to be using this every single day of your engineering career. Right out of the gate, let's talk about why this matters so much. As a DevOps engineer, if you don't master these specific tools, it literally leads to catastrophic operational disasters. We're talking unauthorized access to our infrastructure, massive security breaches, nasty permission conflicts that just break our applications, and a complete inability to track user activities when things inevitably go wrong. And trust me, they do go wrong. Your job is to make absolutely sure none of these things happen on our watch.
Okay, let's dive right into this training curriculum. First up, avoiding chaos. Then, managing users and groups, real-world permissions, package managers, and finally, your Day 2 practice checklist.
Section 1. Avoiding chaos, the multi-user reality.
So we really need to wrap our heads around the multi-user reality of the systems we're operating. A fundamental concept you've got to grasp is that Linux supports multiple users concurrently. And hey, we aren't just talking about human beings here. On any given server, you might have developers writing code, admins managing the system, an automated Jenkins user deploying builds, and an Nginx user serving web traffic all at the exact same time. If you don't have strictly isolated user accounts for these different roles and services, well, everything just becomes a tangled mess. You simply cannot track activities or prevent system conflicts if everyone and everything is sharing the exact same access.
Section 2. Managing users and groups, the gatekeepers.
Now, what's really interesting about this slide is the exact architecture of how Linux tracks who's allowed to do what. Check out these three crucial files. The /etc/password file, that stores your essential user information. The /etc/group file handles your group information. And critically, /etc/shadow is where the really sensitive stuff, the password hashes, are securely stored. You need to know these paths by heart, seriously, because they are the ultimate source of truth for system access.
So, how do we actually create these entities in the real world? It's a very deliberate step-by-step process. First off, to create a user, you'd run sudo user-add sachin. Now, once that user exists, they obviously need a secure password, right? So you run sudo password sachin. But here's the thing. We don't manage permissions on an individual basis. That is way too hard to scale. We use groups. To create a specialized group for your team, you simply execute sudo group add DevOps. It's simple, it's clean, and most importantly, it's incredibly secure.
Section 3. Real-world permissions, the Jenkins scenario.
Okay, I want you to put your problem-solving hats on for a second. Let's look at a real-world scenario. Jenkins is our continuous integration tool, right? And it absolutely needs access to Docker to build our application containers. But giving Jenkins full root access? No way. That is incredibly dangerous. If Jenkins gets compromised, the whole server is compromised. So how do we give Jenkins exactly the access it needs to Docker, and absolutely nothing more, without handing over those super dangerous root privileges?
Well, this brilliantly illustrates the elegance of Linux permissions. The answer is literally this single command: sudo usermod -a docker jenkins. Instead of giving root access, we simply add the existing Jenkins user to the Docker group. Boom! It's safe, it's highly targeted, and it perfectly follows the principle of least privilege. But listen, as junior engineers, you must always verify your work. Never, ever just run a command and blindly assume it worked. You can verify group assignments by just running group sachin, or in our previous scenario, groups jenkins. This quick, simple command verifies your setup and helps you track user activities perfectly. Do not skip this step.
Section 4. Package managers, the tool belt. Let's move on to package managers, because you need to see how this builds our core tool belt. These are what we use to install software securely, but they actually change depending on your specific Linux distribution. If you're running Ubuntu, your package manager is apt. On CentOS or RHL, you'll be using Yum or DNF. And if you're working with those really lightweight containers using Alpine Linux, you're going to use APK. You're absolutely going to encounter all of these here at CloudBridge, so make sure you memorize this mapping.
Let's look at a practical workflow on Ubuntu just to make this concrete. Say we need to get the Nginx web server running. We run through a rapid sequence. First, sudo apt update. That refreshes our lists of available software.
Next, sudo apt install nginx to actually install the package itself. And finally, to update our installed packages to their newest, most secure versions, we run sudo apt upgrade.
Now, part of being a good DevOps engineer is cleaning up after yourself. If you no longer need a package, you must remove it to reduce your server's attack surface. On Ubuntu, that command is sudo apt remove nginx. And just as a quick cross-reference, remember that if you were setting this up on CentOS, the equivalent install command would be sudo yum install nginx.
So, the crucial point here is connecting all of this back to our core job, keeping the infrastructure locked down and safe. Let's look at a very real-world threat flow. Imagine a server is discovered to be vulnerable. Your immediate DevOps action? Update those packages quickly using the exact tools we just talked about. The result? We patch those security issues instantly, long before a breach ever happens. Package management isn't just about downloading cool tools. It is quite literally your frontline defense mechanism.
Section 5. Day 2 Practice Checklist. Your next steps.
All right, I want you to log into your sandbox instances and execute these actionable tasks immediately. First, practice creating users. Then, create groups and assign your users to them. Third, use your package manager to install nginx. And once it's up and running, immediately remove nginx. Finally, as a pro tip, make sure you know exactly how to check the version of what you just installed by running nginxv. This hands-on practice is exactly how you're going to solidify today's learning.
I want to leave you with a rather provocative question to think about as you start your practical exercises. Is your infrastructure truly locked down with proper groups, or are you just one outdated package away from a catastrophic security breach? Think about that for a minute. Remember, this explainer is just the beginning of your journey here. Please hit that like button, subscribe to the Cloud Rage Tech Labs channel to get notified about Day 3, and I will see you all on the command line.